Do you want to know who is the founder of thermodynamics? Can we convert the whole heat into work? How can we calculate efficiency of a heat engine? Is it possible to construct an engine with 100% efficiency? How can we construct most efficient engines? What are the processes which are taking place in most efficient engines? Is the construction of Carnot engine practically feasible? For all these questions, you have answers in this lesson. In this lesson, we have background of Carnot cycle, construction of Carnot engine, assumptions in Carnot engine, processes taking place in Carnot cycle, efficiency of Carnot engine, and Carnot theorem. Background of Carnot cycle. In the beginning of 19th century, steam engines played a crucial role in the development of both industrial and transportation sectors. However, the theoretical calculation of efficiency of steam engines was not explored till the beginning of 1820s. In the beginning of 1820s, Nicolas Leonard Sadi Carnot, he was a brilliant mechanical engineer, military scientist, and physicist in French army, studied the conversion of heat into work, and also he studied the efficiency of steam engines. Based on his studies, in 1824, he published a book. The name of the book is Reflections on the Motive Power of Fire. In that book, he proposed a theoretical thermodynamic reversible cycle. It was later named as Carnot Cycle. Publishing of this book was considered as the starting point for the thermodynamics in modern science. In that book, he also proposed, idealized, and hypothetical steam engine which operates on Carnot cycle. It was named as Carnot engine. Due to his multiple contributions to the thermodynamics, he was considered as father of thermodynamics. Later, the work of Sadi Carnot was developed by Clausius, Clapeyron, and Kelvin, and they developed so many concepts in thermodynamics, such as second law of thermodynamics and concept of entropy. How do we construct most efficient engine, that is Carnot engine? Carnot engine consists of cylinder filled with 1 mole of ideal gas, hot reservoir. It is also called as source, cold reservoir. It is also called as sink, and a non-conducting stand. If you take the cylinder, it contains two non-conducting sidewalls and a non-conducting piston and conducting base. In Carnot engine, the temperature of the hot reservoir is Th and the temperature of the cold reservoir is Tl. Here the hot reservoir supplies QH amount of heat to the engine. The engine will do W amount of work. The remaining part of the heat QL will be supplied to the cold reservoir. Assumptions in Carnot engine. In Carnot engine, the processes which are taking place are reversible. The working substance in Carnot engine is a perfect ideal gas. When there is an expansion of a gas in cylinder, there is no friction between cylinder and piston. The side walls of cylinder and piston are perfect heat insulators. When there is a heat transfer between source and system and sink, there is no change in heat temperature of source or sink. The process is taking place in Carnot cycle. In Carnot cycle, we can find two isothermal processes and two adiabatic processes. The first process is isothermal expansion. The second process is adiabatic expansion. The third process is isothermal compression. And the fourth process is adiabatic compression. Isothermal expansion. In this process, QH amount of heat will be supplied from the source to cylinder. The volume increases from V1 to V2. The pressure decreases from P1 to P2. The temperature of the cylinder will be TH. Transfer of cylinder from source to stand. Adiabatic expansion. In this process, the volume increases from V2 to V3. The pressure decreases from P2 to P3. And the temperature decreases from TH to TL. Transfer of cylinder from stand to sink. Isothermal compression. In this process, the volume decreases from V3 to V4. The pressure increases from P3 to P4. There is a transfer of QL amount of heat from the cylinder to sink. Transfer of cylinder from sink to stand. Adiabatic compression. In this process, volume decreases from V4 to V1. Pressure increases from P4 to P1. And there is an increase in temperature from TL to TH. By this process, there is a completion of cyclic process. This is the PV diagram of Carnot cycle.
Let us recap some important points in thermodynamics. According to first law of thermodynamics, the change in internal energy equal to Q plus W. In isothermal process, the change in temperature is equal to 0 and the change in internal energy equal to 0. Q is equal to minus W. In adiabatic process, delta Q is equal to 0. So change in internal energy equal to work done. In isothermal expansion or compression, the work done W is equal to RT ln Vf over Vi. Here Vf is the final volume and Vi is the initial volume. In adiabatic expansion or compression, the work done W is equal to change in internal energy equal to Cv into Tf minus Ti. Here Tf is the final temperature and Ti is the initial temperature and Cv is the molar heat capacity at constant volume. We know that in adiabatic processes, Tv power gamma minus 1 is equal to constant. That implies T1 V1 power gamma minus 1 is equal to T2 V2 power gamma minus 1. If you take the process BC, at B we have volume V2 and temperature TH. At C we have volume V3 and temperature TL. So the equation will be TH V2 power gamma minus 1 is equal to TL V3 power gamma minus 1. If you take the adiabatic process, that is dA, if we apply the above equation, you will get TH V1 power gamma minus 1 is equal to TL V4 power gamma minus 1. When you divide these two equations, there is a cancellation of TH terms on left side and TL terms on right side. So finally you will get V2 over V1 power gamma minus 1 is equal to V3 over V4 power gamma minus 1. That implies V2 over V1 is equal to V3 over V4. That implies V1 over V2 is equal to V4 over V3. Let us take each process and heat transfer, work done and change in internal energy in each process in Carnot cycle. The first process is isothermal expansion. In this process, the change in internal energy equal to 0. The work done by the system minus W1 is equal to RTH ln V2 over V1. The heat transferred to the system is equal to work done by the system is equal to RTH ln V2 over V1. The second process is adiabatic expansion. In this process, the heat transferred is equal to 0. The change in internal energy delta U2 is equal to CV into TL minus TH. And the work done by the system minus W2 is equal to CV into TL minus TH. The third process is isothermal compression. In this process, the change in internal energy equal to 0. Work done on the system is equal to plus W3 is equal to RTL ln V4 over V3. And heat transferred by the system to the sink minus QL is equal to RTL ln V4 over V3. The last process, adiabatic compression. In this process, the heat transferred is equal to 0. The change in internal energy equal to CV into TH minus TL. It can be written as minus CV into TL minus TH. Here the work done by this on the system is equal to plus W4 is equal to CV into TH minus TL is equal to minus CV into TL minus TH. If you take the full cycle, the heat transferred is equal to plus QH minus QL is equal to RTH ln V2 over V1 plus RTL ln V4 over V3. The work done is equal to minus W1 plus minus W2 plus W3 plus W4. Here there is a cancellation of minus W2 and plus W4 terms. So finally the work done by the system is equal to minus W1 plus W3. So the equation will be RTH ln V2 over V1 plus RTL ln V4 over V3. The change in internal energy in the cyclic process is 0 since internal energy is a state function. In cyclic process, the change in internal energy will be 0. Net work done by the engine minus W is equal to QH plus minus QL. It can be written as RTH ln V2 over V1 plus RTL ln V4 over V3. We know that V4 over V3 is equal to V1 over V2. So the equation will be RTH ln V2 over V1 plus RTL ln V1 over V2. We can write ln V1 over V2 as minus ln V2 over V1. So the equation will be RTH ln V2 over V1 minus RTL ln V2 over V1. So it can be written as R into TH minus TL ln V2 over V1. And efficiency of Carnot engine, that is eta. It is the ratio between net work done by Carnot engine and heat absorbed by Carnot engine. Here the net work done by Carnot engine is equal to minus W and heat absorbed by Carnot engine is QH. So the equation is QH minus QL by QH. QH minus QL can be written as R into TH minus TL into ln V2 over V1 and QH is equal to RTH ln V2 over V1. Here there is a cancellation of R terms and ln V2 over V1 terms. So you will get TH minus TL by TH. Here TH is the source temperature and TL is the sink temperature. It can be written as eta is equal to 1 minus TL by TH. We know that the temperature of the sink is always less than the temperature of the source. So if you take the ratio between TL and TH, it should be less than 1 and greater than 0. So the efficiency eta will be in between 0 to 1. When the temperature of the sink is equal to 0, eta is equal to 1. It means the efficiency of Carnot engine is equal to 100% when the sink temperature is 0 Kelvin. But practically reaching 0 Kelvin is highly impossible. It means the temperature of the sink never be 0 Kelvin. So the efficiency of even most efficient engine, that is Carnot engine, always less than 100%.
Carnot theorem. According to Carnot theorem, the efficiency of Carnot engine, that is reversible engine, is greater than the efficiency of heat engine, that is irreversible engine. Suppose if you take irreversible heat engine 1, reversible heat engine 2, that is Carnot engine, reversible heat engine 3, it is also Carnot engine. All these three engines working between TH and TL. If you take efficiency of first engine and second engine and third engine, the efficiency of first engine always less than efficiency of second and third engine. So eta 1 is less than eta 2 and eta 1 is less than eta 3. Suppose if you take two reversible engines which are working between same temperatures, then the efficiency of the engines will be equal. That is eta 2 is equal to eta 3. According to Carnot theorem, the two engines are working between same temperatures, then the efficiency will be equal. I hope you have got all the answers to the questions. The father and founder of thermodynamics is Nicholas Leonard Sadi Carnot. We cannot convert the whole heat into work because some part of the heat should be transferred to the sink while converting some amount of work. The formula of efficiency of an engine eta is equal to Th minus TL by Th or QH minus QL by QH. We cannot construct an engine with 100% efficiency. For this, the sink temperature should be 0 Kelvin. We know that the reaching of 0 Kelvin is practically not feasible. We can construct most efficient engines based on construction of Carnot engine. The processes taking place in Carnot engine, that is most efficient engine, are the processes which are taking place in Carnot cycle. We cannot construct most efficient engine, that is Carnot engine, because the processes which are taking place in Carnot engine are reversible. Practically, the processes which are taking place in heat engine are irreversible.
Thank you very much.